Let's talk about third-class levers. Okay, how do we get the mechanical advantage for a third-class lever? It's the same process. So we're going to be, mechanical advantage is going to be D in over D out. Now, what makes this a third-class lever? Every lever is going to have a fulcrum. Every lever is going to have an input, which, okay, I'll say it basically is called effort. Probably in the gizmo it's called effort. And then there's going to be the what I call the output, and maybe the gizmo is going to be called the resistance force. And what makes this a third-class lever is, notice where the fulcrum is, and notice where the input force is, and notice where the output force is. Why isn't this a second-class lever? On the second-class lever, both forces were on the same side. Well, let's go back and look. Let's see. Okay, on a second-class lever, if you look, the output force is closer to the fulcrum than the input force. Okay, so basically and that's the second-class lever. Look what's happening here, though, is now the output force, the load, is further away from the fulcrum than the input force. So they're switched. But the process to get mechanical advantage is still the same. All right, so let's figure out. Let's go through that same process. Where's the fulcrum? Okay, I think my fulcrum is, I'm still going to just, okay. That's a problem. I'm going to go back because things have moved. Let's go back. Go back. I don't want any motion. Okay, so I think I'm good now. Let's figure out where the fulcrum is. The fulcrum is here. Okay, I'm going to pretend it's actually right on that line for counting purposes. Just because it moved, the thing moved, and I didn't want it to move. All right, so basically there's the fulcrum. Here's the input. So this is our in. This is our F. And here's our out. Okay, so what's D in? Count the blocks. Okay, 1, 2, 3, 4, 5. Okay, so the input, no, I don't want blue, I want black. So the input is going to be 5 blocks. Goes on top, always on top. And the output, let's count. Well, I know that's 5. That's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, 15 blocks. Blocks cancel out as 1. And what do I get? I get basically 1 over 3. What? You mean I'm going to get less force out? A machine that gives you less force out than what you put in? What kind of machine is that? It's a very valuable machine. In fact, you have many of these types of levers in your body, which we'll talk about in a future lesson. But basically, so yes, you're going to get less force out. So it sounds crazy, but true. So if your load weighs 100 pounds, you're actually going to have to come up with 300 pounds of force. That's crazy. Well, let's make it a little more realistic. Let's make this like 10 pounds. And let's make this, so this will be 30 pounds. Okay, because you could do that. You could push up with 30 pounds. Why the heck would you ever want to do that? Well, for some reason, in this, a third-class lever, you're not interested in getting more force. You are not interested in getting more force out of your machine. What you're interested in getting is more distance. So if you kind of push up that far, you're going to get 3 times the motion. So a third-class lever, basically, what you're looking for is more motion than you put in. You're looking for a greater output distance than what you put in. And what's the price you pay? There's always a price you pay with machines, is you're going to have to put in more force. That's a third-class lever. It works the same calculation, all of them. So find your fulcrum, find your input, find your output. Fulcrum, input, output. And then Measure the distance from the fulcrum to the input. That goes on top. Measure the distance from the fulcrum to the output. That goes on the bottom. That's how you get mechanical advantage of a lever. Doesn't matter which class lever.